we have, let's do 2x squared plus 3x minus 5 equals 0. So there's a couple of main strategies to do this, but they're all about the same. And so we'll do it in the strategy where we move the constant to the right-hand side of the equation and then play with this kind of stuff until it becomes a perfect square of a binomial, well, kind of like we did in the single example last time. So let's maybe lay this out in steps. So step 1, let's say maybe that is move the constant to one side of the equation. So that's going to give us something like 2x squared plus 3x equals positive 5. And then step number 2 is to divide by the coefficient of x squared. And that's because we want this thing on the left-hand side to be as simple as possible. And it's simplest if we have a coefficient of 1 right here. So let's say that we're going to divide by the coefficient of x squared. So that's going to leave us with x squared plus 3 over 2 times x equals 5 over 2. Good. And then the next game is that we want to add something to both sides of the equation. Well, and it's got to be the same thing. We want to add the same thing to both sides of the equation that makes the left-hand side nice. And it turns out that we can get a handle on what we need to add just by this coefficient right here. And so let's kind of lay it out here and then we'll talk about why it works. So step number 3. So add the coefficient of x over 2 squared to both sides. So that's what's going to work in this case. And that has to do with this like standard formula for like a plus b quantity squared that we saw like in the last several days. So what does that mean here? Well, so notice the coefficient of x is 3/2. So that means we're going to want to add 3/2 squared, but that's going to be 9/4. So we're going to add 9/4 to both sides of the equation. So let's see, that gives us x squared plus 3/2 x plus 9 over 4 equals, so we have 5/2 plus 9/4. And then we might as well like simplify the right-hand side of the equation while we're at it. So we can rewrite 5/2 as 10 over 4 just by finding a common denominator, which allows us to write that right-hand side as 19 over 4. Great. And then step 4 is to factor the left-hand side of the equation. So that would be like this thing right here. And we're going to use the standard factorization formula for a square binomial. In other words, it's going to look like this. A squared plus 2ab plus b squared equals a plus b quantity squared. And I should say this is really a plus or minus 2b. AB plus b squared is a plus or minus b, because you might have a minus sign there. And I want to point out that in this setup, we actually always know what this b is, and this b is always oh, I realized I made a mistake here. This should be 9 over 16 because we're supposed to take half of it. So 9 over 16, we take half of this, which would make 3/4 square it, 9 over 16. So let's fix that real quick. So 9 over 16, 9 over 16. So now we can rewrite this as 40 over 16. So that's going to be 49 over 16. So 40 over 16. So we can actually use this motivation here to always know what the b is. So let's point that out. So we always have, and I'm going to put this in quotes because this is like kind of the role being played by b or whatever. So b is going to be equal to the coefficient of x divided by 2. Great. So we calculated the coefficient of x divided by 2 over here. So in this case, the coefficient of x divided by 2 is 3/4. So that means we can factor this left-hand side as x plus 3 over 4 quantity squared. So notice that's the coefficient of x from this part over 2. This is step 4. Great. And then on the right-hand side, we have 49 over 16. Great. So now I want to point out that we're almost home free now. All we have to do is solve. So that's going to be step 5. So step 5, solve. And here we're going to use this thing that we talked about last time, which is if, maybe I'll use capital X here, x squared equals c, then x equals plus minus the square root of c. And this is when c is bigger than or equal to 0. If c is less than 0, then there's no solution. Okay, so let's go ahead and do that. So that means we're going to get x plus 3 over 4 equals plus minus the square root of 49 over 16. But luckily, we know what the square root of 49 over 16 is in this case. This is really just lucky. Most of the time we won't. So the square root of 49 is 7. The square root of 16 is 4. So this gives us plus minus 7 over 4. Now, I would say the thing to do right now is to break this up into 2 cases. One with the positive square root and one with the negative square root. So the positive square root will give you x plus 3/4 equals 7 over 4. And the negative square root will give you x plus 3/4 equals negative 7 over 4. Okay. Now we can subtract 3/4 from both sides. And let's see, that's going to give us x equals, so subtracting 3/4 from the top equation, that's going to give us 4 over 4 or just 1. And then subtracting 3/4 there, that's going to give us negative 10 over 4, which is 5 over 2. So here we get x equals negative 5 over 2. And if you look at this, I bet we could have actually factored this thing, but that being said, it's nice to do one of these with completing the square when we could have factored it because the calculations are nicer than if we would not have been able to factor it. Okay, so let's maybe do one more, and then I'll have you guys try one, and then we'll move on to like kind of the next stuff. So these 5 steps are just the standard steps to follow when solving by completing the square. So I'll erase the steps, but that's what we'll do each time. Okay, great. So let's say we've got this 3x squared minus 24x plus 5 equals 0. Okay. So we're going to follow the same strategy that we did before. So I'm going to go ahead and take this and write it as 3x squared minus 24x equals negative 5. So I've moved the 5 over. In other words, I've moved the constant term over. So that's like step 1. So step 2 is to divide by the coefficient of x squared. So the coefficient of x squared is 3. So we're going to divide this entire equation by 3. So that's going to give us x squared minus 8x equals negative 5 over 3. There's not much you can do with the right-hand side. That's just going to be a fraction. Okay, now we enter the portion where we're actually completing the square. This is really just setup for completing the square, like putting it in a nice format. Now to complete the square, we'll take half the coefficient of x and square it, add that to both sides of the equation. So half of -8 is -4, squared is 16, so that means we're gonna add 16 to both sides of the equation like that. Now that's gonna allow us to factor the left-hand side as a perfect square. So this is gonna factor like x minus 4 quantity squared, and you can check that that works. Notice we get x times x is x squared, x times -4 is -4x, and then we get another one of those from foiling it out, and then we get -4 times -4 is 16, so we're good to go. This is how this left-hand side factors now. Now we maybe wanna simplify this right-hand side, so we could multiply 16 by 3 over 3 in order to give it a common denominator. Notice that 16 times 3 is 42. 48 is 48. Now we've got 48 minus 5 over 3, so that's going to be 43 over 3. Now we can start taking the square root and doing a plus or a minus. So let's go ahead and do that. Taking the square root of both sides, we get x minus 4 equals plus minus the square root of 43 over 3. But there's nothing you can do here. Like, there's no nice square root for 43 or 3. So that's as simple as you can write the right-hand side at this point. Now, I would break this up into two cases, and that will give us our two solutions. So we have x equals 4 plus the square root of 43 over 3. So that's what we get from the positive square root. Notice I've just added 4 to both sides. Or x equals 4 minus the square root of 43 over 3. Again, like here we have one of these. So here, this green plus is from this one. And then this purple minus is that solution. So we get two solutions. Okay, great. So let's maybe go ahead and try one. I'll give you guys like 3 minutes or so to try one of these. Then we will expand this to the quadratic formula. So try. So this is by completing the square. Let's say it's x squared plus 2x minus 4 equals 0. Okay, so I'll give you a few minutes to give this a go, and then we'll look over it and then move on to our next bit of stuff. Okay, so let's go ahead and look at this. So we want to follow the same strategy, although we can adapt this strategy a little bit as needed, but we'll just go ahead and follow the same strategy each time for consistency. So I want to move the constant from the left-hand side to the right-hand side of the equation. So that's going to leave me with x squared plus 2x equals 4. So next thing that I want to do is divide by the coefficient of x squared. The coefficient of x squared is 1, so we're done. We don't have to worry about that. So that's good. Now, next, what we want to do is take the coefficient of x, half it, and square it. So if we take half of 2, we get 1. Squared is 1. And now we're going to add that to both sides of the equation. So adding it to both sides of the equation, we get that. But the magic that happened is that that allows us to factor this left-hand side as x plus 1 quantity squared. So we can check this by foiling it out if we want to, but it's good to go. And then the right-hand side of the equation is going to be, well, 5. So the next thing that we can do is take the square root of both sides. That's going to give us x plus 1 equals plus minus root 5. And then just like we did over there, we can get two solutions out of that, one out of the positive square root and one out of the negative square root. So we'll get x equals -1 plus the square root of 5, or x equals -1 minus the square root of 5. And we get that by subtracting 1 from both sides of the equation. And I should point out that sometimes we might want to write this in the following way, kind of all at once. Could subtract 1 from both sides of the equation there, and we get x equals -1 plus or minus the square root of 5. But, you know, that's just exactly the same thing as writing both of these kind of separately. Okay, good. So next thing that I want to do is generalize this to get the quadratic formula, and then look at a couple of assorted examples. And then if we have time, we want to move on to rational expressions. So we've been working with polynomial expressions and solving polynomial equations. But the next thing that we're going to do is these so-called rational expressions. We may or may not get there today. We'll maybe just touch the beginnings of it at the end. Okay. So let's go ahead and put a heading on this as, well, it's going to be the same thing that we had before. So solve by completing the square. So that's what we're going to do here. Except instead of me writing down an equation that has numbers that we know, we're going to write down an equation with numbers that are more arbitrary. So let's say we want to solve ax squared plus bx plus c equals 0 by completing the square. We're going to follow exactly the same steps that we did when we worked on our examples. So step number 1 is to move the constant over. So in this case, c is the constant because it's the number that is not attached to the x or the x squared. So moving c over will give us ax squared plus bx equals -c. So that's like our first step. Then the next step is to divide by the coefficient of x squared. So that's what we did in all of our examples. The coefficient of x squared here happens to be a. So we're going to divide this whole thing by a, or multiply by 1 over a, that's the same. So let's see what that gives us. That's going to give us x squared plus b over a times x equals -c over a. Great. Now we're going to figure out what number must be added here and here that completes the square. And recall that that is always half of this squared. So let's do that like a little bit at a time. Let's take this, take half of it. So notice if we take half of it, we're going to get b over 2a. And then now let's square it. So maybe I'll put some parentheses there and a squared to mean that I'm squaring it. So that's going to leave me with b squared over 4a squared. Because I squared the numerator and the denominator. 2 times 2 is 4, a times a is a squared, so on and so forth. So that means this is the special number that I need to add to both sides of the equation in order to put it in the right form. So let's maybe add this to both sides and see what we get. So we'll get x squared plus b over ax plus b squared over 4a squared equals b squared over 4a squared minus c over a. Great. So remember, I added this. So let's maybe note that. So I'm going to add this to the left and the right hand side of the equation. And that gives me my next step. Now the step after that is to factor. And the good thing here is that even though this looks heinously complicated on the left-hand side, we can recall that the factorization will always factor in terms of this thing right here. And that's by the perfect square of the binomial thing that we talked about before. So that means that this guy, the whole left-hand side of the equation, is going to factor like x plus b over 2a quantity squared. Now you can check that that's how that foils out, but it works. So we get x times x is x squared, x times b over 2a is, well, it's b over 2a times x, but we have two of those. So when we add them together, we get 2b over 2a, which just simplifies to b over a. And then finally, we get b over 2a squared, which gives you that last term. Okay, nice. Now the next thing that we want to do is combine the right-hand side of this equation by finding a common denominator. So the common denominator here will be 4a squared. So we can build up the denominator of c over a by multiplying by 4a to the numerator and the denominator. Okay, so let's see what that gives us. So that's going to leave us with b squared minus 4ac over 4a squared. Now, it's probably starting to look familiar, like the quadratic formula from like an algebra class or something. Next thing that we want to do is take the square root. So that gives us x plus b over 2a equals plus minus the square root of b squared minus 4ac over 4a squared. So I took the square root of both sides, but we're in luck because this denominator is a perfect square already. So we can rewrite this as plus minus the square root of b squared minus 4ac over 2a, where I've taken the square root of that denominator. And now we can subtract this b over 2a from both sides. Notice we already have a common denominator for those fractions. So that gives us x equals negative b plus minus the square root of b squared minus 4ac all over 2a. And this is, well, like from an algebra class, hopefully somewhere in your past. This is the quadratic formula. So let's maybe notice that. So quadratic formula. So you might say, well, why did we do all of this completing the square if we just get the quadratic formula in the end? Well, from here on out, we can use the quadratic formula if factoring is not available to us, but it is still useful to keep this completing the square strategy in mind because there are times to use it maybe in the future where the quadratic formula is not applicable. So just to reiterate here, if you've got this quadratic equation, ax squared plus bx plus c equals 0, then you have two solutions. Well, actually, we're going to talk about that in just a second. We get solutions x equals negative b plus minus that square root of b squared minus 4ac all over 2a. Now, I want to point out a couple of things. First of all, if b squared minus 4ac is positive, then that means there are two solutions. Because check it out, that's the stuff that's under the square root. If the stuff under the square root is positive, then when you take the square root, you get something that's positive. So you get negative b plus or minus a number over 2a, so you get two different solutions. Now our next possibility, so possibility number 2, is what if b squared minus 4ac is equal to 0? So if that's equal to 0, that means you only get one solution because notice this part vaporizes and you get negative b plus minus 0. Well, adding 0 and subtracting 0 is the same thing, so you only get one solution there. So let's write that. So one solution. And then, well, there's going to be one more case, and that is what if it is negative? So if b squared minus 4ac is less than 0, then that tells you you have a square root of a negative number. But for us, square roots of negative numbers don't exist. You know, they do exist as complex numbers or as imaginary numbers, but we're not going to worry about those. Not because it's really hard or anything, but it's just not useful for our purposes at the moment. So what we'll say is that this has 0 solutions. So no solution. Just like the first couple of examples had parts of them that didn't have solutions. And that's because we would have a square root of a negative number, which is not a real number. And then just sort of by the way, we'll use this maybe kind of offhand. So it'll be useful to know like a word for this object, this b squared minus 4ac object, and it's called the discriminant. So the discriminant of this quadratic polynomial is this b squared minus 4ac. And notice the discriminant tells you how many solutions this equation has. So you can often find out the number of solutions an equation has without even finding the solutions at all. And that's sometimes an interesting property, the number of solutions that an equation has instead of finding the solutions. Okay, good. So now let's do a couple of maybe assorted examples. So some of these will involve the quadratic formula and some of them will involve factoring. So let's maybe write it like this. So assorted examples. So let's say maybe we'll do this one first. 3 minus 2w minus 1 quantity squared equals 0. So we've got really two main choices. One choice is we totally expand this right-hand side. Then we've got a quadratic equation that we can maybe use the quadratic formula for. But that's actually a bit overkill because if we look at this, this is like in the middle or actually near the end of the steps that you would do in order to solve this by completing the square. So let's just solve it with the rest of those steps. So I'm gonna add this 2w minus 1 squared to both sides. So we're thinking about this as an equation for 2w minus 1 squared. So that's gonna leave me with 2w minus 1 squared equals 3. Kind of switched to the sides of the equation, but you know that doesn't change anything. Now I can take the square root of both sides. That gives me 2w minus 1 equals plus minus the square root of 3. That gives me 2w equals 1 plus minus the square root of 3. There I added 1 to both sides of the equation. Now I can divide by 2. That'll leave me with w equals plus minus the square root of 3 over 2. Then if you wanted to write this as two separate equations, we would get w equals 1 plus root 3 over 2, or w equals 1 minus root 3 over 2. So there are our two solutions. Now, like I said, we could have multiplied this out and used the quadratic formula, and that would be totally fine. You know, just as good in terms of getting a solution, but not quite as efficient as noticing that this is actually partway through a simplification already. Okay, let's look at another one. All right, so let's say we have 5x minus x times x minus 3 equals 7. Okay. So we really need to, okay, so let's like step back a little bit. So what we need to first determine is, do we need to expand this all the way out and solve it by factoring or using the quadratic formula, or is there a trick? And in this case, we have to factor it all the way out, or sorry, expand it all the way out. And that's because We could factor an x out of the left-hand side, but notice that's going to give us like this product of some stuff on the left-hand side equals 7. But that's not super helpful. The only way to solve these is to get 0 on one side of the equation, or have some nice setup like this, but that isn't going to help. Well, let's maybe like reiterate this real quick. So we could factor an x out of the left-hand side. That's going to leave us with x times 5 minus x minus 3 equals 7. Or it's going to leave us with x. And then notice this is the same thing as, well, 5 minus minus 3 is 8. And then minus x equals 7. But we can't solve this. This is not something squared, so we can't take the square root. And it's not something equals 0, so we can't say, oh, x equals 0 or 8 minus x equals 0. So while this is perfectly true, this was not helpful. But I should say that if the 7 was a 0, then that would have been like a nice trick for doing this. Okay, great. So let's expand this out instead and see what we get. So expand. So let's see, we're going to get 5x minus x squared plus 3x equals 7. So we get something like that. Then maybe we'll move that 7 over and then combine the 5x and the 3x. So that's going to give us negative x squared plus 8x minus 7 equals 0. Now you could certainly factor this as is, but I would prefer to have a 1 in front of the x squared instead of a minus 1. So let's maybe go ahead and take this entire equation and multiply by negative 1. So that's going to change the sign everywhere. And if we change the sign everywhere, it'll just be a little bit easier to factor. So that's going to leave us with an x squared minus 8x plus 7. So we need to think, should we factor this or use the quadratic formula? So I would say always try to factor it first, because after you've practiced the technique of factoring, it's actually quite a bit quicker than using the quadratic formula, and it like builds intuition for these kind of calculations. So notice if it factors like x minus something. We know that because we have a plus there and a minus there. So they product to a positive number but sum to a negative number. And then they need to multiply to 7 and add to negative 8. So that's not too bad. We get 7 and 1. So that means we have x equals 7 or x equals 1. Those are our two solutions. Okay, good. Now, let's maybe look at one more. So let's look at 2x squared equals 3x to the 4th minus 6. Great. So again, this is like a quadratic equation that's kind of in hiding, because we can use the fact that x squared is x to the 4th. So it's really like a quadratic equation where our variable is x squared. So let's set this up so that it's equal to 0. So we have 3x to the 4th minus 2x squared minus 6 equals 0. So again, the first thing that we'd like to do is try to factor this. So the only factoring that will work is with a 3x squared and an x squared. That's because 3 is prime, so it only factors like 1 times itself. Now we can split 6 up one of 2 ways. So here's like a little thought bubble. We can write 6 as 1 times 6 or as 2 times 3. And let's see if any of those work to get us a 2 here. So if we put 6 here and 1 here, that's not going to work because we're going to have 18. That's way too big. If we put 6 here and 1 here, that's not going to work because we're going to have something like 3. Now what if we put a 2 here? So that's going to be 6. And then a 3 here. So that's not going to work. What if we put a 3 here and a 2 here? or sorry, a 3 here and a 2 here, so that's going to be 9. So that's not going to work either. So after testing all of those really quickly, so this does not factor, which means we need to use the quadratic formula. So we'll use like negative b plus minus the square root of b squared minus 4ac all over 2a, except now we're solving for x squared instead of x, because we have this whole thing as a quadratic equation where our variable is x squared. So we'll get x squared equals, so negative b, so that's going to be 2, plus minus the square root of b squared, so that's going to be 4, minus 4 times a times c. Well, 4 times a times c. So let's see what that is. 4 times 3 is 12. 12 times negative 6 is negative 72. Yeah, so we've got plus 72. All over 2a, so that's going to be all over 6. So we get something like that. But now notice we can simplify that a little bit. That's going to be 2 plus minus the square root of, well, 4 plus 72 is 76 all over 6. Now, maybe we can factor some perfect squares out of 76. So let's see, I think we can factor a 4 out of 76. So 4 divided by 76, well, let's see what that is going to be. 119. So that's going to be 19. So that means we can rewrite this as 2 plus minus the square root of 4 times 19 all over 6. But next, we can take this 4, extract it from the square root, and it turns into a 2. So let's see what that gives us. Okay, so that's going to give us x squared, I'll bring that over, equals, so it's going to be 2 plus minus 2 times the square root of 19 all over 6. But now notice we can like factor a 2 out of the numerator and cancel with the denominator. And that's going to leave us with 1 plus minus the square root of 19 over 3. Great. But that's what x squared is. That's not what x is. That's actually two solutions for x squared. We have x squared equals 1 plus the square root of 19 over 3, or x squared equals 1 minus the square root of 19 over 3. Just splitting that plus or minus up into two equations. Now, something really important to notice here is that this has no solution. And why does that have no solution? It's because 1 minus the square root of 19 is negative. So we get x squared equals a negative number, but then by some stuff we talked about last time, there's no solution to that. There's no real number that squares to something that's negative. So that means we can throw away that possibility. That doesn't work. And then we just have to solve this one. But solving this one is as simple as saying that this is equal to plus or minus the square root of 1 plus the square root of 19 over 3. And that's it. So the solution looks kind of heinous, but that's what we get. We get this kind of crazy quantity involving these nested square roots as the solution to this equation. Okay, good. So I want to look at a couple more of these assorted type examples, and they involve these quadratic equations along with absolute values. So what I want to do is maybe do one of them where we do the first step together and I let you guys finish it, and then we'll do one where I let you guys try the whole thing. So let's say this is our first example. So we have the absolute value of 2x minus x squared equals the absolute value of 2x minus 1. Good. So recall how to solve an absolute value equation. You can get rid of the absolute values if you change everything to a plus or a minus. So that's going to split this thing into two separate equations. So the first equation will be 2x minus x squared equals 2x minus 1. So that would be like taking the plus, or taking the minus, we'll get 2x minus x squared equals negative 2x minus 1. So again, let's maybe recall the strict rule here. We have the following rule. So the absolute value of A equals the absolute value of B. So that means that A equals plus minus B. So we did this kind of stuff a bit earlier with like linear equations. You guys did pretty well on the exam problem, well, on the whole exam, but on the exam problem involving these like absolute value linear equations, you got to split it up into two cases. Okay, so maybe I'll give you guys like 3 minutes or so to take these home, to the end, I should say, and then we'll look at one more, and I think that'll be it for today. Okay, so just to reiterate, give a few minutes on those, and then we'll look at it. Okay, so let's go ahead and look at this problem, which actually turned into two problems. So the same strategy is going to apply. We're going to want to set this up so that we have 0 on one side of the equation. So let's see what we can do here. We can subtract 2x from both sides. So that's going to cancel that. And unmute. Okay, so like I said when I was on mute, so like I said when I was talking to myself, you can subtract 2x from both sides because they have the same coefficient and sign, so those cancel, and then we'll add x squared to both sides, and that leaves us with the equation x squared minus 1 equals 0. Now you can solve that two different ways, by factoring or by adding 1 and taking the square root. It's essentially the same. Let's maybe factor it this time. I think we added and took the square root a previous time, so just kind of for variety. So we get x plus 1, x minus 1 equals 0. So that means x equals 1 or x equals negative 1. Okay, good. Now let's go ahead and look at this one. So we're going to have 2x minus x squared equals, I should say, the first thing that we're going to want to do is expand this right-hand side of the equation. So that's going to leave us with a negative 2x plus 1. Now we can move everything around so that we have 0 on one side of the equation. Maybe I'll add x squared to both sides and subtract 2x from both sides. So add x squared minus 2x. So that's going to leave me with x squared minus 4x plus 1. Notice everything cancels on this left-hand side, and then all of this is what's going on the right-hand side, but I'm just switching the order so I've got something like that. Now you might try to factor this, so you'd want to look for two numbers that multiply to 1 and add to negative 4, but that's not going to work. So you probably want to use the quadratic formula. So that means x equals negative b, so that's going to be 4 plus minus the square root of b squared minus 4ac. So b squared is 16 minus 4ac, so that's going to be 16 minus 4, which is 12, all over 2. Great. And then maybe it's important to notice that 12 is equal to 3 times 4. So we can use that to take this 4, which is inside of the square root, and factor it out of the square root. It becomes a 2. So we have 4 plus minus 2 times the square root of 3 over 2. So again, what we did, this 12 became 2 times the square root of 3 by writing 12 as 3 times 4, taking the 4 outside of the square root, and then taking its square root. And then we can cancel this 2 in the denominator with the 4 and the 2 in the numerator. 2 goes into 4, 2 times, goes into 2 1 time, so we get 2 plus minus the square root of 3. So that gives us 2 more solutions. So notice in total, we have 4 solutions. We have 1, -1, 2 plus the square root of 3, and 2 minus the square root of 3. Okay, so here, let's... We don't really have time to like sort of sit and try this one, but let's maybe look at this. X squared minus x plus 3 equals 4 minus x squared. Okay, so we're gonna break this up into the positive part and the negative part, just like we did in the last one. So we'll have x squared minus x plus 3 equals 4 minus x squared, or x squared minus x plus 3 equals -4 minus x squared. So again, we split this up into 2 things, just like we did working with the linear equations a while ago. Okay, great. So now let's go ahead and move things around here so that we solve for 0. So we'll add x squared to both sides, and then we'll subtract 4 from both sides. So that's going to leave me with 2x squared minus x minus 1 equals 0. Then I think you have to use the quadratic formula for that one, because you want 2 numbers that multiply. Well, they got to multiply to 2 like this, but add to -1. No, actually, I think that'll work. So let's say we'll have 2x with something, and then x with something equals 0. Notice 2 is a prime, so we know that that has to work like that. And then also, the only way to get 1 is 1 times 1. So we can put a 1 there and a 1 there, and then we just have to choose a plus here, or a minus here, a plus here, a minus here. But what's going to work is a minus here and a plus here. So if we check that, we get x times 1 is plus x. 2x times minus 1 is -2x. That's going to add to -x. So we're good to go there. Notice that's going to give us x equals -1/2 from this one, or x equals 1 from the other one, setting each of those individually equal to 0. So there we get those 2 solutions. Now next, let's expand this right-hand side. That's going to leave us with x squared minus x plus 3 equals -4 plus x squared. Now notice that we have got an x squared and an x squared on both sides of the equation. Those just cancel. And then we can subtract 3 from both sides of the equation. That gives us -x equals -7. But then changing the sign, we get x equals 7. So in this case, we get 3 solutions, -1/2, 1, and 7. Okay, so I mean, we're essentially out of time, so we'll stop here. I will try to put the video up from today up in the next today or tomorrow or something. I recorded the audio externally, so because I'm not super happy with how the audio is on the recordings, so hopefully that will help the audio on the recordings. I'll just sync it like in post or whatever. So anyway, keep that in mind if you choose to watch them or not. They don't get a huge number of watching, but I think it's nice to have them there for prosperity or whatever. And I'm also going to try to find some time to make some example type videos on this kind of stuff. So if you guys want to email me what types of examples do you guys find trickiest, I can make some just like more well-produced example type videos for these as well. Okay, great. So again, we're like pretty much out of time. So there'll be a homework up for this posted that'll be due on Saturday. And then if you guys need anything, let me know. I'll see everyone next time.